I'm Anil Kumar, and in this video, we'll explore the future value formula for annuities and try to find the value of n. The question here is, how many equal monthly payments would you have to make to get 100 times the amount you are investing in each month if you are earning 9.6% per annum compounded monthly? So in this particular question, we are given the value for R and future value, the regular payments and future value, as a ratio of 100. We are also given the value of interest I. We need to find N. You can pause the video, answer the question, and then look into my suggestions. So what we are given here is, we are making regular payments R. So R is a regular payment. And the future value we want is 100 times the amount you are investing. That means 100R. And we are given interest I as 9.6% per annum. And this is compounded monthly, right? So compounded monthly. So when this is compounded monthly, we can find, this is actually the rate of interest which we can find in compounding periods, which is I. I should write this as R. This is the rate of interest. So I is compounded monthly. It'll be 9.6 is 0.96. 0.096. We'll divide by 100 and then by 12, right? So that gives us, let's do it, 0.096 divided by 12 equals to, in decimals, 0.008. So I is 0.008 compounded monthly. So let's substitute these values and find the value of N. So future value is 100R. So we'll write 100R equals to R times, within bracket, 1 plus I, which is 0.008 to the power of N minus 1, divided by 0.008. To find N, let's divide by R, multiply by 0.008. So we get 0.008 times 100R over R, which is 1.008 to the power of N minus 1. So let's use the calculator. We can add 1 also in this, right? So what we have here is R and R will cancel. So if you multiply by 100, you will get 0.8, right? So multiplying by 100, add 1 to it, plus 1 equals to 1.008 to the power of N. So that is 1.8 equals to 1.008 to the power of N. And now we need to find N from this particular equation. So how do we do that? Now one method to do it is to use logarithms. So we can take log both sides and then solve for N. So let me rewrite this equation here. We have 1.8 equals to 1.008 to the power of N. If I take log both sides, I get log of 1.8, and this is N times log of 1.008. And N can be found as ratio of log of 1.8 divided by log of 1.008, right? That is how you can get the value of N. So let's calculate this value. So we have log 1.8 divided by log 1.008, and that gives you around N equals to 73.76, let's say 7, right? So N is 73.767. So N is the number of terms, number of months in this case, since it is compounded monthly. So you can say 73 more than 73. So N is equals to 74 months. Right? So that is how you can find the value of N. So in this case, we use logarithms. Now, some students may not know this method. Now, for them, it is trial and error, right? So for them, you could actually, assume some value and then trial and error. So 1.008, let's say exponent of try 70, for example. So you'll get some answer, which is close to 1.8, 1.74. And then you can try 1.008 to the power of, let's say, 75. And then it is slightly more, and then you try 74. So likewise, you could actually do by trial and error if you have not learned this logarithmic formula, right? It's easy to do. Use properties of logarithms to find. So that is the ratio of log of these two terms, right? Log of 1.8 divided by log of 1.008 gives you n, right? I hope that helps. We'll take few more examples like this. That should help you. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.